excuse me. What we're trying to figure out here is that sometimes you're going to get exponents that don't work as clean as you had hoped. And you have to be able to solve for this setup. Now, we all agree that this value is going to be in between those guys, right? So basically it just means that within your exponents, it's going to be somewhere between 2 and 3. So what we have to do here is figure out what's that exponential value to get us 2 to what power is 6. And this is where logs come into play. Okay. This is where logs come in. What happens here is that you can get, blow this up just enough here, is that the value of x is going to equal log of base 2 of 6. And I'll show you guys how we solve these things with the calculator here in a little while. Excuse me. So as you can see, basically if you raise 2 to about 2.585, it would equal 6. Roundabouts. Now, your calculator will allow you to figure out these decimal equivalents, but first, to start out with today, and probably into tomorrow, we're going to be working with rewriting expressions via logs, how you write them in log base, is what one called, or exponential values. Going back and forth, and then we're going to start working on what are called inverses, how you can simplify. I know my throat's starting to go bad. We're going to work on graphing these. And we're going to work on other one called natural log. That's that LN button on your calculator you've seen. So this is where we're headed. Logs. Basically, the following holds true. Log of base b of y equals x if and only if, remember this, if, did Steph show you guys that before?
Yeah.
IFF? B to the x is 1. Those two equations are equivalent. Those two equations are equivalent to one another. We talked about that a second ago. 2 to what power was 6? If I look at that, is that written in terms of log or exponents? It's written in terms of exponents. So in this case here, my b value is 2, my y value is 6, and x is, well, that's x. Everybody agree on that? If I rewrote that in terms of log, it would be log of base 2 of 6 is x. That's what we're looking at. How to rewrite going from exponential to logarithmic, or logarithmic to exponential, going either direction. Again, when we had that written out, we had, our first example was 2 to the x was 6. Well, that implies that we say log of base 2 of 6 is x. These bases, that little value of 2 is a subscript, so it's usually written a little bit lower. Sometimes when I'm writing these out, I might get lazy. It might look like it's part of the value of 6, but I try to make it over-exaggerated that it's lower, so you understand that's the base. Not so bad? You guys probably have worked with logs in Chem, haven't you? I thought you would. Physics? You remember physics? How do you guys use that? Oh. So let's take a look at this. There's a couple of special values that occur. You have log of 1. These are just two very simple, common ones that you see. So log of any base of 1 equals 0, because b to the 0 is 1. Remember, if you raise anything to the 0 power, it's always 1. What they're saying here is no matter what that base is, base 1, base 2, base 3, base 10. Base 10 is the standard. And then the other version of it is, if you take anything to the first power, it's yourself. So they're just using properties of exponents and rewriting them in terms of logs. You probably would have recognized those two before, but you've just never seen it written as a log. The reason why I wanted to show you that is because sometimes when they're giving you problems to simplify, they'll throw in those quick ones in there. And, anything to the 0 power is 1. They'll throw that in there just to throw you off. Okay. That shouldn't be so bad. So let's look at this in terms of all the different bases and how these things are being moved. For example, if I say log base 2 of 32 is equal to 5, what would that look like in exponential form? Yes. 2 to the 5th is 32. Good. That's it. Again, remember, the idea here is this. These two guys are what we're going to be working with a lot today. Over and over and over again. Okay? Over and over again. Log base 5 of 1 equals 0. 5 to the 0 is 1. Everybody see that? Just by rewriting it out into the exponential form. You all right?
Yeah, I'm not. Just get on old age.
Yeah, it's tough, isn't it?
It sucks.
Log base 10 of 10. 10 to the 1 is 10. Yeah. Oops. One thing I will show you is sometimes they will write it like this. If it's in base 10, it might just say log of 10 is 1. If you don't see a little base there, if it's not written in as a subscript, it is implied that it's base 10. That's the only one that it'll ever be. Okay? So if you ever just see the word log, it's automatically going to base 10. The word log on your calculator, when you press log there, it's automatically it's awesome. Anyway, if there's a button on your calculator that says log, if you press the button that says log, it's automatically implying that's in base 10. There will be, you can show it back there. You missed our song, I'm sorry. I know, you'll get over it, I'm sure. There will be times we will have to change the base within calculators. We'll get to that point later. But does everybody see the button on the calculator that says log?
Yeah. Yes.
So log to the log base 10 of 0.1 is negative 1. Dios mío. Bless you. What is that going to equal? Yeah, 10 to the negative 1 is 0.1. We don't normally write it as a decimal, though, do we? What will you write that as? 1/10. Oops, that looks like a 16. What happens in this section here, when they're dealing with logarithms, they normally go to decimals. Why, I don't know. It's just one of those things. Okay. Log base 1/2 is 2. Yeah. 1/2 to the negative 2 is, excuse me, 1/2 to the negative 1 is 2. Again, what we're doing here, guys, is just rewriting these things going from log base to exponential. Okay? Trying not to be too fancy with it today. So take a second and write those. Yeah, Sean, the main idea right now is this. The log, these two statements are equivalent. Top one is what we've called logarithmic. This is exponential. What do you get for the first one? Okay. What about the next one? Yeah, now. What about the next one? Okay. Again, your notice is probably not very scary, is it?
That's gonna get harder.
Of course it will.
Wait, what is the log for?
What's that?
What is the log for? Are we making a log for it?
It was kind of a joke
Oh.
because we did logs, log fort, log roll. Schedule on the wall.
I wanted to make
Building a log fort.
And then Thursday?
We're having a log roll.
I get those.
It's a joke. It's a joke. It's a joke. It's a joke.
No,
I can't make jokes.
no.
Why?
Because this class doesn't have a sense of humor.
Sorry.
Because I get confused.
And then lastly, 19 to the 0 is 1. Again, log base. Okay, switching back and forth. Here's where things get more interesting.
How did we evaluate?
How do we evaluate? I'm glad you asked. If you look at the first example here, right, it says log base 3 of 81. Basically what you're asking yourself is 3 to what power is going to equal 81?
Oh. Okay.
3 to what power is going to equal 81? 4. Good. Now, what you're doing here is that there's really no buttons yet that we can press that's going to solve that value. I can't undo an exponent, can I, in my calculator? No. How do I get to that? How do I get that to drop to itself? See what I'm saying? We haven't gotten there yet. But we do know the following. I can rewrite 81 as 3 to the 4th power. Do you agree? Do you notice now how they both have the same bases?
Yeah.
They both have the same base of 3. That means you can set their exponents equal to each other. So what we're getting at is some of the properties. We're going to talk about why this here and here is very important over the next couple of days. I'm not going to get into it yet. We're working towards that. Again, what we're trying to do is figure out what that base raised to what power is going to give you the value. Here we have 5 to what power is going to equal 0.04. Now, -2, good. Now, what I would have done is, what is 4 hundredths? 1/25. If I look at this as far as a fraction is concerned, because sometimes you might understand that a little bit easier. Everybody see that? By reworking it that way, sometimes you might, sometimes if you work it from the decimal into a fraction, you might remember that, oh, 1/25. Well, that meant that the 5 wasn't happy where it was. It got sent to a denominator. That meant it had to use a negative exponent. And that's where you get x was -2. Everybody okay with that? Do you know how to convert fractions and decimals in your calculator?
Yes.
Okay. You do? Okay. What's nice with this one, if you just put in 4 divided by 100, and then you can simplify the fraction that way as well.
Sorry, why is it negative?
Again, notice when you have,
How do you get -2 out of 1/5?
Because you have to flip it.
are you okay with me saying that this is log base 5 of 1/25?
Yeah, that's
Okay. So this is 5 to some power equal 1/25. Now, this is 5 squared. Everybody okay with that? If it was 5 squared, it would have been 25. But if it's 5 to the -2, it would be 1/25. What we've done there is that we've used that negative exponent to make the fraction.
Wait, didn't it say x equals 2 on the other slide?
I had -2 there,
Okay,
didn't I? Yeah.
okay, I didn't see the negative.
Oh, that's okay. So again, what we're looking at here is can we create fractions with these? You remember if you have to go with that, we use negative exponents. Could you use your calculator to work your way through finding some of these if you had to? By a little bit of guess and check to start with. Some of these values should be the ones that you should be able to figure out off the top of your head. It's kind of like simplifying a square root. You know, we all know what the square root of 8 is, right? Two root 2, thank you. Let's try the other ones. Okay, let's take, oops. Take a look at those two. Log base of 1/2 of 8. Very good. Again, this is the same idea of thinking 1/2 to some power is going to give me 8. When we switch from a fraction to an integer, that usually means that you have to use a negative exponent because that means you're flipping the fraction. Everybody remember those little properties? Yeah, I know. So again, 2 to what power gives you 8? 3. This is why you get x is -3. Because if you substitute that back in, using your properties of exponents, you get that. Okay? 9 to what power is 3? Well, if it was -1/3, that means I'd flip it over and take a cube root. 1/2, very good. What does the 1/2 power mean? You guys remember that? Square root. 1/2 power meant square root. This was 9 to the 1/2. Okay? So again, a couple things to remember from previous things that we've done. When you're working with exponents, remember the x to the 1/2 is a square root. Anything to a negative means you flip it. If you have a fraction to a negative exponent, it becomes, you flip it around again. Okay? Those are the kind of the three of them that you see a little bit more than anything else. The other ones you should be able to pick up on. It's 2 squared and whatever. Yes, sir.
X to the 1/3 is cube root. Cube,
Correct.
right?
Yep. Yep. I'll write that one in here too. Yep, that's using the nth root stuff. Okay. Jan. Let's see. I might talk a little bit about inverses here. Again, I don't want you guys to worry. I don't want to explain this out cleanly. No, we'll do a little bit of inverses today. We'll pick up more on the inverse, like the natural log inverse stuff tomorrow. But we'll talk briefly about this simple inverse. What's happening here?
So how about that weather on this?
What's happening here is that anytime you have a log, when you're dealing with logarithms, we have a base. Do you guys agree? There's some base b. And when you're dealing with exponents, you also have a base. You have that base raised to a power. So what happens when you're dealing with logarithms, if there's logarithms and exponents put together, is if their bases are the same, they drop out. Let me show you a numerical example. If I say the log of base 3 of 3 to the x, Mommer? Thank you. If I say log base 3 of 3 to the x, the base of the logarithm is 3. You agree?
Yeah.
The base of the exponent written out is also 3. Our last time I checked, is 3 the same thing as 3? Okay. So what happens here is that these guys basically cancel each other out. And what you're left with is the exponent. they drop out. It's kind of like doing the following. What's 1/3 times 3x? X. Division is the inverse of multiplication. If you have those setups there, your bases, if the bases are the same, the exponent just drops down. Okay? It works the same way if you have, it works the exact same way if you write it out in terms of exponents. Let's say it's 4 to the log base 4 of x. Again, I have an exponent that has a base of 4. I have a logarithm that also has a base of 4. They're put together within the same statement. Those two bases are the same. What does it simplify out to be? I have x. It just drops to become x again. They're inverses of one another as long as you have the exact same base. Yeah, just x. It inverses itself out, just like when you multiply 1/3 times 3, they drop out, becomes 1. And the reason why we use this is because when we start talking about logarithmic equations, that's going to allow us to be able to drop bases to work with exponents. By taking the logs of both sides of the equation, you're able to work with those bases. Remember how I had that example here a second ago where we had, what was it? 3 to the x was 81, I believe. You know how we rewrote that as 3 to the x was the same thing as 3 to the 4th? See how these two bases are the same? If those two bases are the same, the exponents fall. That's where you get x equals 4. That's one of the properties that we're getting to. All I'm doing here is just showing you how that's going to eventually work. So this is by taking the logs of both sides. With that, it drops things out. So that's how you're able to solve these equations eventually. You look like you're ready to ask a second. Okay. Real fast, I do want to introduce you guys to something called the natural log. I think we talked a little bit about that, the LN button on your calculator last week. The natural log is, I think it originally it was called the log of the natural. I just made that up.
Goes in the Yukon.
Yes, this is the Yukon. We talked about this a second ago. Log base 10 is the same thing as just saying log. They're synonymous with one another. It's kind of like implying that in front of a variable, if you don't see a number, it's 1. So if you don't see a base written out, it's always assumed that it's a base 10. The natural log is a logarithm that has a base of e. Natural log if the base is e, it's called a natural log. We use that a little bit more, well, solving equations. When we get into solving some of the equations, I just wanted to get you guys to show you where it came from. We're not solving any equations today. What we're doing today is we're going to be rewriting, going back and forth between exponential, logarithmic, and then trying to solve some of the very simplistic ones. You know, 3 to what power is 81, things like that. Okay. Excuse me. So let's simplify these two. If I look at that first one, I have 10 to the log of 2. 10 to the log of 2. What's the base of that log? How did you know it was 10? Because it's implied. Very good. So again, do these guys have the exact same bases? 10 and 10 are the same base, aren't they? What happens to the exponent? It drops and becomes 2. The next one you got to do a little bit more work. The next one we got to do a little bit more work, don't we? I have a log base 3 of 9 9x, or 9 to the x, excuse me. In order for our nice little trick to work to get that exponent to drop, that base 3 of the log has to be the exact same base as the other one. Can I rewrite this 9 in terms of a base 3?
Yeah.
How?
9.
3 squared. Okay, good. So this is the same thing as saying log base 3 of 3 to the 2x. I just brought the exponent up. Everybody okay on that?
Yep.
Okay, so what's it simplify out to be? 2x. Again, what you want to do is you want to get those bases to be the same. And today, the problems you're going to have are going to be very simplistic, very similar to something like that, just to start getting in the role of seeing how this stuff's going to work. And yeah, my goal this week really is to get through 8. This is what, 8-4? We'll do 8-4 and 8-5. Probably start 8-6 on Friday. We're not going to quiz this week. I think what will happen is that we'll be able to finish out this chapter by next Thursday. And there's only like 3 or 4 more sections to go through. That way we can just pace ourselves out and be able to do it then. Because we don't have school next Friday. So I think I'm just going to set the test for next. It's an institute day. On Valentine's Day. I don't know. But the following Monday, we go to school. Yeah, we actually have to go to school for 5 days this week. I know it's going to be tough. What's that? No, 3 inches. That's it.
For what?
3 inches, long comes at like
3 inches of snow. That's it. So what I want to look at tonight.
I'm not kidding. Let's take
See if you can simplify these.
No, we should seriously.
Simplify those 4 real quick before I give you some problems. Simplify those 4. See if you can figure them out. Simplify them by trying to rearrange some of the bases. Excuse me. Oh, man. What'd you get on the first one? 6. Good. Perfect. This is log base 2 of 2 to the 6, so you get 6. Which one? Yeah, the last one. 4. Yeah. What do you get for the next one? 1/2. Excellent. Everybody get 1/2?
I only got one.
What's that?
I only got the first one.
Oh. Again, if you think about what it's asking you, 25 to what power is going to give you 5? It's the half power of it. You're going to fall back and forth between these things by remembering that these two are equivalent. It's the easiest way to switch back and forth if you don't pick up on it real fast. The next one, it's the same thing as saying 6 to some power is 1. 0. Perfect. Exactly. It's got to be 0. And now what about the next one? 4. Everybody see how it's just going to be 4? Remember, if you don't see a base here, that means it's the same thing as 10. So you have a base raised to a log of the same base. The exponent just drops out to become 4.
What's the answer to 12?
The last one is just 4.
Okay.
Okay? So let me give you guys a handful of these to try out for tonight. It's basically rewriting and some simplifying. I'm not going to get into any of the graphing yet. There's graphing with this, but again, it's just as easy as the other stuff was. Exponential growth and decay. This brings your table sets all the time. So there's going to be H's and K's, but it's very, very, very straightforward. Okay? So let's try this for tonight. On page, this is section 8.4. Let's try those for tonight, okay? We'll get more involved with the inverses tomorrow. Actually solving the inverses tomorrow and graphing it. Okay?
How much time do we have left?
The last one? How it was 10, the last one was, it was 10 to the log of 4. When you don't see a base for the logarithm, it's implied that it is 10. So it just becomes 4. Very good. Alright? Give those a shot for tonight. It's just some simplifying, rewriting, things like that. Shouldn't be so bad.
They got into 4th year, everyone else, but they were still.